Welcome to the first module in Applied Calculus for Information Technology. This is a review lesson. While many students find the core concepts of calculus approachable, the real challenge often lies in the algebra required along the way. Algebra is the essential language of mathematics, crucial for solving complex problems, especially in calculus. It forms the foundation upon which calculus is built. To ensure your success in this course, we'll start with 2 lessons focused on key algebraic skills. Mastery of these skills is vital. They will make your journey into calculus smoother and more intuitive. We begin with factoring. Example 1. Okay, so in this problem we're trying to factor 4x squared h squared minus 12x h cubed plus 22x squared h cubed. And when we look among these terms here, we can see that there is a 2 factor in each one of these. There's also an x factor, and there's an h squared factor in all of these. So there's a common factor of 2x h squared among all of these. Now, if we factor that out, which is essentially just dividing each term by that, then what we'll be left with right here will be 2x, and the h squared is gone because that's been factored out. Here we have minus 6, the x is gone, 2 of the h's are gone, so that leaves us with just an h, plus 11xh. And we can't factor that down anymore, so that's our final expression. Example 2. Okay, so here we're trying to factor 4r squared plus 11r minus 3. And there are different ways we could approach this. I think the easiest way is just to write down a couple of binomials, and what we put here in the first terms has to multiply up to 4r squared. And there are different things we could try. We could try 4r and r, or 2r and 2r. I'm going to try 4r and r and just see if we get anywhere with this. If not, we can come back and try the other one. Now what I put here for the last terms has to multiply up to negative 3. And so again, I have different things I could try. Positive 1 and negative 3, or negative 1 and positive 3. Let's try a positive 1 and a negative 3. And we want to know, have we factored this thing correctly? Well, if we did, then when we multiply this out, we would end up with our middle term here, which is 11r. Now, that comes from multiplying the outer and the inner terms here. And the outer ones here, it looks like that would give me a negative 12r, and the inner one here would give me a positive 1r. And we can see here that negative 12r and positive 1r does not add up to a positive 11r. So it looks like I haven't done this one correctly. So we give it another try. I've got 4r and r, and this time I'm going to try negative 1 and positive 3. Now when I multiply this out, I'm going to take the outer terms, which is 4r times 3, that gives me a positive 12r, and negative 1 times r gives me a negative r. Looks to me like that gives me the 11r that I was looking for. And so I have factored this thing correctly. Example 3. We wish to factor the expression 25y squared minus 9. Now, one thing I can notice here is that I've got a difference of squares. So let's start by just writing down the difference of squares formula. We have a squared minus b squared, and this can always be factored down into a plus b times a minus b. And we can check that just by multiplying this out. We see the outer terms would be negative ab, the inner terms would be positive ab. Those cancel out, just leaving me with a squared minus b squared. And so if I recognize this as a difference of squares, then it's just a matter of asking, well, what is a and what is b? So what do I square to get 25y squared? And that would be 5y. And what do I square to get 9? And that would be 3. So we get 25y squared minus 9 is equal to 5y plus 3 times 5y minus 3. And we've factored it. Let's move on to fractional expressions. In example 4, we want to write this in lowest terms, 5xh over 2h. We know this is a fairly easy problem. What we do is just look for common factors between the numerator and the denominator. In this case, we would have an h that would cancel out in both cases. However, we need to be a little careful here because the only way that this could cancel out is if we know that h is not equal to 0. So we're going to write this down as 5x over 2, where we're canceling out the h's, but let's also just sort of write down over here that we're assuming that h is not equal to 0 when we do that. In the next example, we want to write this in lowest terms. In this case, we've got 4xh plus h squared plus h, all of that in the numerator, divided by 5h in the denominator. Now, what we want to do here is we want to cancel out any common factors we have between the top and the bottom. And it may be tempting to say that we can cancel this h with this h that's occurring right here, but remember, this is a factor of the entire denominator. We can only cancel that with a factor of the entire numerator. So if we factor out an h in the top first, and write this as h times 4x plus h plus 1, and put that over 5h, now these h's can cancel out. And what we end up with is we have 4x plus h plus 1 in the numerator, and we have 5 in the denominator. Now we might take this one step further, and this is something that we often see in calculus, is that we want to take these types of expressions and break them down a little bit more. So I can write this as, let's see, I've got 4x over 5, so I'm going to write that as 4/5 x plus h over 5, so I'm going to write that as 1/5 h. And then I've got 1 over 5 over here, so I'm going to write that as 1/5. And I've got an expression here that's in lowest terms, and it's pretty much as simplified as we can possibly get it. Example 6. So I'm trying to write this in lowest terms. I've got 2x squared plus 6x minus 36 in the numerator and x minus 3 in the denominator. Now don't be tempted to cancel this x with any of the x's you see in the numerator, or cancel this 3 with anything up here that you see. The only way we can cancel anything is if we have a factor of x minus 3 in the numerator. So let's see if we can achieve that. Now I'm going to start by factoring out up here in the numerator. Looks like I could pull a 2 out, which will leave me with x squared plus 3x minus 18. And all that is over x minus 3 in the denominator. And it looks like I've got a trinomial here, which might be able to be factored down. Let's factor it down. Let's see. Okay, I've got x and x. Negative 18. I need some numbers here that will multiply up to negative 18. I'm going to try negative 3 and positive 6. And I'll just check that real quick. If I do the outer ones, it looks like I get a positive 6x. And do the inner ones, I get a negative 3x. And when I add those together, I end up with this positive 3x over here as my middle term. So everything looks good here. And now I see I have a factor of x minus 3 in the numerator. So I'm going to cancel that with the x minus 3 down here. And it looks like what I'll be left with will be 2 times x plus 6. And let's just make a note here. Now the only way we could cancel these x minus 3's is if x was not equal to 3. So I'm going to just sort of write that down over here and say that this expression equals this one as long as x is not equal to 3. Example 7. We want to simplify 5 minus 2x in the numerator divided by 5. Now, one common error that I see a lot of times here is just to see the 5 up here and the 5 down here and think that we can just cancel those out. But remember, 5 is kind of tied to this entire thing up here in the numerator. We can't just cancel part of the numerator out with what's in the denominator. The best we can do here is maybe split things up. If I write this as 5 over 5 minus 2x over 5, then we can simplify a little bit just by rewriting 5 over 5 as 1. And so I get 1 minus, and I'm going to write this as 2/5 x. And that's about as simplified as we can get with that problem. Example 8. Simplify x to the 3/4 divided by 3/4. Now we can approach this in a couple of different ways. I think the easiest way here is just to recognize that if we multiply the top and the bottom by 4, then that would cancel out with this 4 down here in the denominator. So I'm going to just take this and I'm going to multiply the top of this and the bottom of this by 4. And this 4 and this 4 cancels out. And it looks like what I'd be left with is an extra 4 up here in the top, which gives me 4x to the 3/4 over, and down in the bottom I'm just left with 3. And if I want to, I could take that one tiny step further and write that as 4/3 times x to the 3/4. In the next example, we want to simplify 3 over x divided by the quantity 2 over x squared plus 1. So I'm trying to simplify 3 over x in the numerator divided by 2 over x squared plus 1 in the denominator. And I'm going to take the strategy here of looking for something that I can multiply this entire numerator by and this entire denominator by that would get rid of these smaller fractions in here. Now when we consider 3 over x and 2 over x squared, the least common multiple here for those denominators would be x squared. So I'm going to multiply the top and bottom of this entire thing by x squared. I'm going to multiply by x squared up here, and I'm going to multiply by x squared down here. And x squared over x squared is just equal to 1 as long as x is not equal to 0. And so we're not really changing anything with the problem. All we're doing is multiplying by 1. But x squared times 3 over x, one of these x's would cancel with one of these. That would just leave me with a 3x up here in the numerator. And when I multiply by x squared here times this entire denominator, now remember you've got to multiply this by both terms, x squared times 2 over x squared just leaves me with a 2, and x squared times 1 leaves me with an x squared. And so we've simplified this down to 3x over 2 plus x squared. Let's move on to exponents. We'll start with some properties about exponents. We have the first property, which is that a raised to the negative n is equal to 1 over a to the n. We also know that the nth root of a can be written as a to the 1 over n. And the nth root of a raised to the mth power is the same thing as a raised to the m over n. So let's move on to the next example. We want to rewrite as a quantity raised to a power. Now for this first one, we've got 1 over x cubed. And we know that there's a property, I'm going to write it down right over here, that we have a to the negative n is equal to 1 over a to the n. And so we can see here that if a is x and n is 3, then this can just be written as x to the negative 3. Here we have the square root of x to the third. Well, the property I'm going to use here will be a to the m over n is equal to the nth root of a to the m. In this case, my m would be 3, my n would be 2. We don't write it, but a square root, there's actually a 2 there. And so I know I can rewrite this as x raised to the 3/2. Well, now in this case, I see that I've got something here, the square root of it. And I've got another property here. It's really just a special case of the second one that tells me that if I've got a to the 1 over n, that's just the nth root of whatever a is. And so I'm going to rewrite this as 1 over 5r minus 2 to the 1/2, since that's the square root. Well, I can take that just a little bit further because I know now that I can take this and write it as a negative exponent. And so this is 5r minus 2 raised to the negative 1/2. And this is an important skill. We're going to see this type of thing a lot when we get into the calculus. Let's talk about solving equations. In this problem, we want to solve for h. We have 2/5 times h plus 18 equals negative 1/2 times h. Now our strategy here will be to see if we can simplify this. I want to see if I can get rid of these fractions to begin with. Now when I look at 2/5 and negative 1/2, I can see that if I were to multiply all the way through by 10, then that would get rid of these fractions. So I'm going to multiply everything here by 10. Now 10 times 2/5 times h is going to give me 4h. 10 times 18 is going to give me 180. And on the right-hand side, 10 times negative 1/2 h looks like that's going to give me negative 5h. And so I'll simplify this thing already. Now let's see, if I were to add 5h to both sides of this equation, or alternately I could think about that as taking this and dragging it across the equal sign, but whenever that happens I have to change signs, then what happens is I end up with a positive 5h on the left-hand side. So I've got 4h that's already over here, and a positive 5h. Now I'm going to do sort of the same thing here with the 180. I'm going to subtract 180 from both sides, or I can just think about that as dragging it over. I end up with a negative 180 on the right-hand side. So 4h plus 5h looks like that's going to give me 9h equals negative 180. And if I divide both sides there by 9, I end up with h equals negative 20. Now remember that whenever we're solving equations, we can always check this answer. If we take h equals negative 20 and go back to the original equation and put in here negative 20 everywhere we see h, I should get the same thing on both sides here. And so that's a way of checking to make sure that you did it correctly. In the next example, we want to solve the equation 4x squared minus 2x minus 12 equals 0. Let's see, I can start by factoring out a 2. And that's going to give me 2 times, I have 2x squared minus x minus 6 equals 0. Now I'm going to see if I can factor this part right here down a little bit more. So I've got a 2 times, and let's just set up 2 binomials. And I get 2x and x. And I need something here and here that's going to multiply up to a negative 6. I think I'm going to try something like maybe a plus 3 and a minus 2. And I'll just check real quick to make sure that this does all the right things. The outer gives me a negative 4x. The inner gives me a positive 3x. Combine those, I will get a negative x in the middle right here. So it looks like everything's done correctly. And now to get all my solutions, what I need to do is set each factor equal to 0. And this is using something that's called the zero property. It says that if you have something times something times something and all that equals 0, then each one of those things has to be set equal to 0 to get all possible solutions. So I have a 2 right here. I'm going to set that equal to 0. 2 equals 0. I get 2x plus 3, and I'm going to set that equal to 0. I have a factor of x minus 2, and I'm going to set that equal to 0. So all my solutions will come from here. Now when I say 2 equals 0, that doesn't give me anything. That's a contradiction. So I know I don't get any kind of solutions from here. Now one common mistake I see is that a lot of times when we have just a number out here, sometimes it's easy to make the mistake that you think that, okay, you're going to get x equals 0 that comes from that. But that's not the case. This 2 right here doesn't give us anything. If it was an x out here, if this was something like maybe a 2x out here, then I would get x equals 0 as one solution. But this doesn't give me anything. Here, 2x plus 3, if I take the 3 onto the right-hand side, and that gives me a negative 3, and then divide by 2, looks like I get x equals negative 3/2. And over here, if I take the 2 to the right-hand side, that gives me a positive 2 over there. And so it looks to me like what we end up with is 2 possible solutions here. We get x equals 2 and x equals negative 3/2. In example 13, we want to solve the equation x squared plus 8x equals negative 16. So I'm going to start by just taking everything and bringing it over to the left-hand side. So I have x squared plus 8x plus 16 equals 0. Well, now maybe we can factor this. Let's give it a try. So we have x and x. Looks like I have something like maybe 4 and 4 and a plus in both places. Multiply that out, you see that we end up with the original expression right here. Okay, so I've got x plus 4 times x plus 4 equals 0. Or I could write that as x plus 4 quantity squared equals 0. All right, so now the solutions I'm going to get come from setting each one of these things equal to 0. But it's the same thing in each case. So I think I can see pretty easily here that I get a solution of x equals negative 4. But remember, this actually happened twice. We had it here and we had it here. And when we have that, what we do is we say, well, yes, this is a solution, x equals negative 4, but because it's actually showing up twice, we often will say that is equal to negative 4 with multiplicity 2. Okay, so we've got a solution, x equals negative 4 with multiplicity 2. In the last example, we want to solve the equation m cubed equals 25m. One thing that we note here is that, well, there's an m on both sides. So why don't we just start by dividing both sides by m? Well, that would be okay if we knew for certain that m was not equal to 0. But we don't know that here. And so we have to take a different approach. How about we just take everything and bring it over to the left-hand side? So I'm going to rewrite this as m cubed minus 25m equals 0. Well, one thing that I notice is that now we can factor that m out, and I get m squared minus 25 equals 0, and all that's multiplied by the m out here in front. Well, m squared minus 25, hey, that's a difference of squares. So let's rewrite that as m minus 5 times m plus 5 equals 0. And to get all of our possible solutions, we're going to set each factor equal to 0. So I set m equal to 0, m minus 5 equal to 0, and m plus 5 equal to 0. And I think I can see here that I get the solution m equals 0, m equals 5, and m equals negative 5. In this section, we've explored several algebra concepts. If you're already confident with these topics, fantastic, you're on the right track. If you're still uncertain, this is the perfect moment to brush up on these skills. Rest assured, a solid understanding of algebra will make your progression into calculus significantly easier.